Okay, so what we're going to do now, hopefully, is make an actual energy storage device using the powder we created in the last video. I have created these little beasties. They are 50 millimeter by 50 millimeter, 5 centimeter by 5 centimeter. I'm going to use those to cut my graphite. I want to have a couple of pieces of graphite that are approximately the right size. It does not have to be perfect. The one thing that I do have to watch for is that when I cut my paper for the separator, that I make sure that it's just that little bit bigger than the graphite pieces so that it does not short out, because shorting out is one of the prime causes of these batteries failing. I have high hopes for this powder. I really do. I think I've identified a number of things in making it. It is absolutely a conductive powder, which I think it would be conductive even without the graphite powder that was put into it. However, I did have to put the graphite powder into it because I believe that's what made the microwave susceptor work so much better, and that's why the mixture got so much hotter, was because it had the graphite powder in it. One of the cups turned over during the microwaving, probably when the tile underneath it broke, and I could actually see the sparking of the mixture, and I think every one of those sparks was like a tiny little lightning bolt of energy and heat, and that heat was exactly what I needed. That because I'm using table salt, sodium chloride, instead of one of the other metal salts that is a better microwave susceptor, I needed that to work. So what I need to do is I will make a glue, and I will paint it on one half of this. See, these are the two halves. So I'll paint it on half of it, and I'll paint it on the other half of this one. I can then assemble it as a sandwich almost, if you will. See how that is. That's there, and goes there, and then the separator will go in there, and this goes there, and this goes on top. And then I take all of this and I clamp it so that it has a nice solid thing, and then I've got the two big ends to take care of it. Now, one thing I'm going to do that is a little unusual, but I've learned, is that this graphite is very weak. It is very susceptible to ripping. Now, I don't like ripped graphite, so I am going to take some ordinary shipping tape here, and I'm going to put it on the side of the graphite that we're not using. I don't believe there's a big difference between the sides of the graphite. You know what? I'm going to test that right now, just to make sure. But I think the two sides are pretty similar in terms of their characteristics. So I'm going to go down to like 200 ohms here on the ohm meter and probe these bad boys. This side about an inch or so apart, says about 18 or so, just real roughly, and this one says about the same on that side. So yeah, the two sides are pretty much the same. When you're using them, it doesn't really matter. But it does matter in terms of being able to protect it. Not that which side is which, but it does matter that I use the tape to stop the ripping. because I'm going to be manhandling these. I'm going to be putting probes on them and such, and it's just easier if it doesn't have a problem. So first this one. Now it turns out that this is, oh wow, that was lucky, 49 centimeters, whereas my other thing is 50. So I have to trim just a little bit around the edges, which is no problem. .48 millimeters, I'm sorry, millimeter, not centimeters, and milli, not centi. I have to trim that down and trim these edges. But the fact that the stiffeners are 2 millimeters wider than the material is actually no problem at all, and actually may be a good thing. Sorry about my phone. Okay, so now I've got this, obviously a super shiny side on one side and the side for the material on the other. See if I can do this one a little more gracefully. The last one just kind of stuck and it was lucky. There we go. I guess it has a little electrical attraction as it first comes up. So now I not only have the graphite, which is a wonderful, fun material, although I guess over the long term it can break down. Short term it's wonderful, it doesn't react with anything. Trim it up. And trim it up. There we go. Now I've got 2 pieces of graphite with the extra material on them. Beautiful. Now, I need to make an ink that I can paint onto this using the powder. The mixture I'm going to be using is 90% powder and 10% binder. The binder I'm going to be using is this stuff. Titebond Ultimate Wood Glue 3, Titebond 3. This one is waterproof. It says it's much more resistant to water than the normal PVA glue. So I can go on ahead and use a saltwater medium and it should be just fine. First, I need to find out this. Now, I'm using this stainless steel crucible. I like it. I like the stainless steel crucibles because it cleans up so nice and easily. However, I wonder sometimes if a ceramic crucible could actually catches the powder and can make a finer thing when you're trying to actually grind it in there and make it happen. So I don't know about that for sure. But here we go. Turn that on. And that's not happy. It should be. Those are fresh batteries. Come on, baby. Okay, be right back. Okay, I got new batteries for the scale, so here we go. First we need to make our ink. I really like this stainless steel beast. Here is the powder that we have. There we go. The way I made this powder is I took the powder out of the microwave from the cups, and then I ground it up in the coffee grinder once again. Then I put it into a coffee filter, and I put it into a coffee machine, into a normal brew coffee machine, and I put in 12 cups of distilled water and let it get hot and pour right on through. So I ended up with this powder. At this point, after everything is said and done, this is saying that I've got about 5.23 grams of actual material, which is a whole lot less than what I started with, but that's okay because I'm hoping that this is the best of the best material. So 5.2 grams, I want to add to that about 1/10 of that in the binder, the Ultimate Wood Glue. So take that and open it up. At least that's the theory. There we go. Okay, so now I'm going to add 1/10, which would be right about half of a gram, which isn't much at all. And there it is. Just a, oh, no. A little bit more. Just a few drops, basically. But that's okay. I'm also going to add some water that will get evaporated. There we go. I also am going to add some water that will get evaporated because I need to be able to stir it up and make a nice ink. But the water won't actually contribute anything to the mixture other than making it possible to make it a nice mixture. Start stirring it, as it were. And yeah, that needs a lot more water, which is fine. I want to have something that I can paint nicely onto the graph oil. Oh, that's going to look nice. I can tell already. The parts that got a little more water, I can tell already this is going to be a nice mixture. A nice ink. I really have hopes. I have not had a lot of success yet. Oh, look at that. Yeah, that's coming in. So it's starting to look like more of a paste. I'm going to keep it going a bit. Get everything mixed in nicely. I'm going to scrape this off. Yeah, I really have high hopes that this will solve some of the issues that I've had where I just have not gotten very good results. But I think by having the hotter microwave, by having the graphite flakes in the original mixture, as well as the table salt, that I'll end up with a nice mixture here. There we go. Oh, what a nice smooth ink. Yeah, this is looking really nice. It's looking like a nice smooth ink. Just a little bit of the binder and a bit of the water. And there we go. Don't really need a whole lot of this because I'm just painting 2 little electrodes. Kind of a shame, but I'll be throwing the rest away for now. But oh yeah, that's a nice smooth ink. Okay, here we go. So let's see. Take some of this scrap so I can paint it on top. Make sure I'm painting the right side. And I'm just going to brush that right on. Cover half of it. And there we go. One of the reasons I'm doing it this way is so that people that know better can tell me if I'm doing something wrong. So please feel free to leave comments about how you would do it differently and what you would do and what's worked for you. because I'm trying to get this to work nicely. And there we go. Okay, so I've got the two electrodes. I've got them coated in the material with just a little hint of the binder, the 10% of the binder. Got them coated in that, and I'll let them dry, and then we'll assemble it. So I'm going to pause the video and then continue it when I'm ready, when these are dry and ready to assemble. I could dry them with a blow dryer, or I can just leave them out in the air, and either way works. And then I'll put them together. What I'm going to be putting them with is a separator made out of tracing paper. I'm going to try tracing paper this time. I've been using paper towels, kitchen towels, but they're a little bit thicker, and I'm wanting to go skinnier, and the tracing paper seems like it'll be finer. And then I'm going to put the same electrolyte that I've been using. I want to experiment eventually with other electrolytes, but I'm going to be using an electrolyte of 1 molar solution of table salt. So I'll talk to you soon, and I'll be right back. The electrodes are now dry, and I have made a 1 molar solution of salt water. That basically was 29.22 grams of salt mixed with, so it's a 500 milliliter solution. So now let's put a battery together and see what happens. Start with the stiffener. I lay down the electrode. I want to put a little bit of the electrolyte on this, because that's the big thing. You really want the electrolyte to be in everywhere. There we go. Now I'm going to put the separator. The separator is just tracing paper with the stuff. I've cut it a little bit bigger than the 60 by 60 square deliberately, because the big thing you want to avoid is any shorting. That you really don't want it to short out. I have high hopes for this. I have not had the level of success that I've wanted, but I have high hopes that this will give me a good performing beast. But we'll see, won't we? So there we go. Put on the other stiffener, and we've made our little sandwich. I'm going to put some pressure into that sandwich. There we go. I hear that you should let it sit for a little while to let everything soak in, especially let the electrolyte penetrate into the active material. We're going to charge it for 5 minutes at a at 2 volts and see what happens. First I want to see something. Sometimes on these batteries you get a kind of a nominal effect where you get a bit of a battery effect where it has a charge even right out the gate. I want to see if this one has that. Shouldn't, in my understanding of theory. And sure enough, okay. I'm not seeing anything. Notice how I'm putting the 2 probes. Okay, so I don't see anything at all. No particular. Let me go down to 200 millivolts just in case. The reason is, oh, okay, now I'm getting 9 millivolts on this. Check it this way. Yeah, sure, 9.5 millivolts. So that tells me that this side is just a tiny bit more positive. So I'm going to keep that. I marked it as positive now. I'm going to keep that as the positive so that I'm kind of going with the natural bent of the thing. So now I'm going to hook it up to the power supply. and charge it up for 5 minutes. I'll get this yet. There we go. So I'm putting the voltmeter in the middle so that I can check on the amps, the current as it charges up. Okay, so I put that on the positive. I'll put this on the negative. So I can move this so that you can see the number as it starts up. There we go. All right, let's see what happens. There we go, and it's charging up. Let's see. Okay, I have the leads backwards. So it was starting up around 60 milliamps. So it is receiving current, and you notice that that's going down. That's exactly what I want to see, because interesting difference between these two. I trust this one a lot more than I do that. This is just a cheap little power supply. It does a good job on the 2 volts, but I don't trust the amperage that I'm getting out of it. But I'm seeing here that the amperage going into the charge is going down, which is exactly what I want to see. So I said 5 minutes, and I think I'm going to live up to that. What I'll do here is I'll start up a timer and there we go. Reset. Yeah, okay, no ads. There we go. So now I've got a timer going, timing the charge. I'll fast forward this part so that you don't have to go through this, and I'll see you in just a bit. And 5 minutes. Okay, now I'm going to disconnect the power supply. I'm leaving the amp meter, leaving this in the loop so we can monitor this. Let's see if this little battery can turn this little propeller. That is my hope. There goes the negative. There's the positive through the, it's coming off of the red, so it's coming through there. Here we go. Oh, let me do this. Reset. And in case this does work, I want to see how long it works for. Alright, so here we go. Oh, it's going to work! And there it goes! Okay, so this is already more of a success than I have ever seen previously, which is wonderful. It's discharging at 6 milliamps, 6.4 milliamps. Just happens to be what this motor draws. I'm already hearing the motor slow down, but I'll take this as a much better thing, because previously I haven't been able to use the motors. Excuse me, I've only been able to use LEDs, and I wanted to use the motors because I like the visual impact of having this. This is the very first charge. Didn't give it any soaking time for the electrolyte. So it could be that the battery will get much better over the next couple runs. But this is fantastic. consuming about 5.5 milliamps now. Slowing down a little bit. I can tell just just by the tone of the motor, but it's over a minute. I know people show various runs going for an hour and this and that and huge amounts of current, and I hope to get there. I'm not there yet, but I hope to get there. Ideally, in my pipe dream, my daydream, I'd love to have an open source set of materials that were crazy safe that could give lithium ion a huge run for its money. That may be a while away from now, but at least I can get started. By the way, please, as you look at this, if you see things that I could do better, let me know. One thing I wonder about, for example, is after I added the binder, I did not include any, I didn't strain the ink before, or the material before I put it on. Should I have? Should I run it through cheesecloth or something? Would you suggest that? What are other things that I can do to improve it? Right now, this is a mixture of salt and sugar. The salt mainly just to concentrate the microwave, and then it has the sugar, and the sugar is a primary source of carbon, and then I had a bit of urea primarily for its nitrogen so that I could get a better atmosphere in the little container while I was mixing it. I'm wondering about adding some garlic powder. That's supposed to be really good. The sulfur in there is supposed to be really good, so I'm wondering about that. And of course, I have lots of ideas and possibilities about different electrolytes. Right now, this is just 1 molar salt water, and there's different electrolytes. I wonder about a mixture, actually, of Epsom salts, the magnesium sulfate, but it also has water in there, and then Epsom salts and urea. Apparently, it makes a liquid that's kind of like a can't even think of the name, but we'll see. We'll see. I have lots of possibilities. This is great. It's been running for 3 minutes, and it's still running. As it slows the motor down, it draws less, so now it's only 3.6 milliamps, but that's okay. I have no problem with that at all. The motor is running, and this is wonderful. I'm going to stop talking, and I'll just fast forward until the end here. Wow, okay, so it lasted for 8 minutes and about 35 seconds or so. Very cool. This is by far the most successful that I've had so far, and it feels good. Feels good. So I think I'm going to give it another charge and see what happens on the second charge. Okay, so this has been a huge, huge success for me. Much better than I've seen before. What I'm going to do now is I'm going to give it a little bit more electrolyte. The battery's on a bit of a slant, so I'm going to put the electrolyte up here at the top, and it may or may not wick in. I just want to make sure that it has plenty of electrolyte. Nice wet cell. And I'm going to let it sit for half an hour, give it one more 5-minute charge, and then turn it on and see what happens. I'll be back in a bit. Alright, the delay is over, and then the first charge now is also over. Disconnect the power supply, hook up the motor, and see what we get. Okay, so the third run, even after the soaking in of the electrolyte, was about the same. But this is the best I've ever seen from my little homemade work, and so I'm pleased. I think the biggest change was the temperature of the material being microwaved. By adding the little bit of graphite powder before microwaving it, I think I got a lot higher temperature, and that did a lot of good things. But I also made the physical size bigger than what I've been using this summer, but not enough bigger that it should have done what it did. So I'm glad to see some success, and now I can move on from here. If you have particular suggestions for what I should try next, please leave it in the comments, and thank you very much. For a lot of guys, this is probably like, oh yeah, I had this kind of success right at the very beginning. Well, that's kind of where I am. So now I can move on from here. Thanks a lot, and have a great day.